So we're going to pick up from there. So I kind of started the table for you. And we called it T. And we said the smallest value we could get was 4, all the way up to the largest value was 11. 6, 7, 8. And the way I started you off was by calculating the one for 4. And that was with 2 and 2. And so 2 and 2 need to happen. We need to multiply them. And I asked you to do that for all the rest of them. And so eventually, here are all the possibilities. So here are all the different ways we could get each possibility. And so all we need to do is pick out which ones are the 4s, which ones are the 5s, and so on, and add them together. That's all the possible values of x and y. Here's when x is 2 and y is 2. Here's when x is 2 and y is 3. X is 2, y is 4. X is 2, y is 5. Right? Each of these have slightly different probabilities. So 0.045 for 4. All the different ways we get 5. We have 0.06 here. We have 0.075 here, and that's it. So that is 0.135. All the different ways we can get 6, that's here, here, here. That's it. 0.03. That's 0.13. 0.235. So go ahead and get the rest of that table. And what I want is expected value. I want you to compute the expected value at the end of it. If you want to double check that you're doing all of these right, all of these probabilities should add up to 1. If you're doing it correctly, just like with any other probability table. All the probabilities, if I put them together, should add up to 1. And then if we looked at yesterday, hopefully you have a prediction of what this expected value is going to turn out to be. So it's going to be 4 times probability of 4 plus 5 times the probability of 5 all the way down. While you're doing that, a quick vocab review, because we're about to talk about it. Standard deviation is our measure of spread. Right? If I take that value and square it, that value is called the variance. So variance is standard deviation squared. Or, working the other way, if you have the variance, then you take the square root of it to find the standard deviation. And I say that because that's about to be relevant in just a minute. There's the expected value for x. There's the expected value for y. Guess what? The expected value for x plus y should be the sum of the two. So the expected value of the sum is the sum of the expected values. And hopefully you went through and verified that. So for your expected value of that table, you should have gotten 6.85 if we did it out the long way. But now we are going to take the shortcut, and instead of making this whole distribution, listing out all the possibilities, and calculating the expected value out that way, on each of these, we are just going to say that if we're expecting on average 3.75 for x, and we're expecting on average 3.1 for y, that means we should expect the two put together to be, well, those two numbers added together. So the expected value of combination of the two is going to be the sum of those expected values. By the way, what that last slide says is that this is all under the assumption that these two variables are independent of each other, right? That one isn't somehow causing the other to happen or have an effect on the other happening. We could also compute the variance or standard deviation. It's that big long formula. I'm not going to go through it in detail. But what I will say is that instead of the standard deviations put together, to get the spread, instead of adding standard deviations like we added the means, what we are going to add is the variances, the standard deviations squared. And I could go through and give you about 15 minutes and make you do the formula, but I'm going to not do that and just tell you that it is the sum of the variances. You could prove it in the same way that we just proved the expected value was the sum of the means. So we are going to take variances and add them together. That means if they give you standard deviations, you may have to turn them into variances. Because adding the variances and adding the standard deviation is not the same. This is an Algebra 2 concept. If I add a plus b and square it, is not the same as a squared plus b squared. There's a middle term here, if you remember. So you have to square each individual piece first to get the variances and then add them together. So remember that you can add variances and you should not add the standard deviations. So if you get two different variables, then you need to combine and add the variances, not standard deviations. Right. So let's look at a, before we do that, if instead of adding the two variables, I subtracted the two variables, what's going to happen is that expected value, if I'm looking for subtracting the two, you're going to subtract the means. But for spread, it doesn't matter whether it's adding or subtracting, you're still going to add the variances. And again, not adding standard deviations. So that's how subtracting is going to affect the spread. Okay, let's do this as an example, and we'll go through a couple together. All right. We want to be in the zone between 8.5 and 9 grams of sugar in the tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with a mean of 2.17 and a standard deviation of 0.08. If we are selecting 4 packets, what is the probability that the tea will taste right? So we'll say S is S for sugar packet. And we are going to, since 4 packets would bring us closest to the target, that's what we're going to use. We're going to use 4 packets. And so, if we are using 4 sugar packets, then T, let's use T for total sugar. Then T is just S plus S plus S plus S. And so we're going to get the mean and standard deviation from there. The mean of T, well, the mean was 2.17. And so since it's combining these 4 different variables, it's going to be the sum of those means. So it's going to be 2.17 plus 2.17 plus 2.17 plus 2.17. Yeah. 2 times 4 is 8. And then if we're adding them 4 times, then we're doubling and doubling again. So 17 doubled is 34, and double it again is 68. Variance, because we don't want to talk about standard deviation. The reason we're talking about variances here is that we are combining together the variables. So that means that when we're combining together the variables, we want to add variances. We don't want to add standard deviations. So I don't want to add 0.8s or 0.08s. I want to add variances. So variance of S is going to be Well, it's right in the notation. Take standard deviation and square it. .0064, or is there another zero? Okay. Just double checking. So that means that our variance, our total variance, is going to be 0.0064 plus 0.0064 plus 0.0064 plus 0.0064. Add it together 4 times. That one? Yeah, it's powers of 2. You guys haven't played enough 2048.
No, the reason I knew what it was 2048, yeah.
There you go. All right.
Which is a problem. Can we talk about that for a second? Anybody who's
No, we can't talk about it for a second because we got to finish problem. Standard deviation. Standard deviation. To get it from the variance, we do what? Square root it. This one I need. 0.16 or 0.016? 0.16? Okay. As I said it, I was like, yeah, that makes sense. I should have been able to do that one in my head. I was thinking 512. 512 isn't a perfect square. But this is 2 to the 8th power. And so that will have a square root of 2 to the 4th, which is 16. Anyway, that's my standard deviation. So that means that my picture of this distribution of the 4 sugar packets put together looks like this. Let's draw the normal curve. Two standard deviations on either side. So I'm going to double check my adding of 16 and subtracting of 16. All right. Where do we want to shade? Because that's where we need to be. And now let's do our normal CDF. So here's the rest of that. in the actual notes themselves. Maybe. Maybe I just don't have it. Maybe it's just gone. Yeah, it's just not there. All right. Fantastic. Disregard that. We're going back to the board. Oh, and it's T for T. That's nice. T was total. That was my thought. But it's also for T. How nice. Okay, I will trust that. That sounds reasonable. I've been practicing. We've been practicing it with just z-scores, and so that's the way that I've been showing it. And because there are some problems where you have to know it as z-scores, and so I don't want us to get too comfortable with the other way and just forget that z-scores exist. I don't know where it went. Let's go hunting and see if we can find anything else. Oh, look, we found a homework assignment.
Oh my God.
How about that?
What in the world?
Incredible.